We are on lesson 4.3 using functions involving e. So e in this case is a number. It's irrational, so think of it kind of like pi. It just has decimals that go on and on and on with no end. It can't be represented as a fraction. It's defined as n approaches positive infinity, then it is 1 plus 1 over n to the power of n, and that is number. So what that means is if you plug in a really high number for n, close to infinity, it's going to get really close to that 2.718281828. Okay, I'll show you. Alright, to show you what I mean by as n approaches infinity, that number approaches the number e. I am going to plug in a really big number for n. So n, let's make it 999999999. And then raised to the power of 999999999. Look about right? I think one less. Alright, and I get a number that looks just like e. Alright, so for the first ones, we are using properties of exponents, so reach back in your mind and remember what those are. So the first one, when our base is the same and we're multiplying, we add the exponents. So for this one, 7 plus 4, so e to the 11th. And then when we're dividing, we subtract, but starting with the numbers, 12 divided by 3 is 4. And then e to the 4 minus 3, which is just 4e to the first, or 4e. So number 4, 24 divided by 4 is 6. And then e to the 8 minus 5, so e cubed. For number 5, remember we distribute the exponent to both terms, so 10 to the third, and then multiply since it's outside the parentheses, so e to the negative 12x. And then 10 to the third is 1 with 3 zeros. Tens are pretty easy. And then a negative exponent means that it goes to the denominator, or it flips. So number 6, 5 squared, e to the negative 6x. And then 5 squared is 25 over e to the 6x. Awesome, now I'm going to show you how to do this on a calculator. Alrighty, whenever we are typing e in our calculator, it is e to the power of x is the second ln button, or just plain e is second division sign, and then you can use the little up arrow to get an exponent. So for number 7, we are doing, I'm going to do second ln, so e to the power of 4, and then enter, and you should get 54.598 blah blah blah. Okay, and for most of these we're just going to be rounding to the nearest hundredth, so I'm just going to keep going. Number 8 is e to the negative 0.09, so e to the, this one's a negative, remember, not this one, that's a minus, 0.09, enter, so 0.91. And then for number 9, e to the 3/4, and make sure the 3/4 is in parentheses, and you get 2.12. Moving on to graphing, this is just like lesson 1 and lesson 2, but now we're adding an e in there, but remember e is just a number, 2.7 something. Alright, so we have exponential growth if the power r is positive and bigger than 0. So if the power r is negative, then we have an exponential decay. So it's just going to change whether our graph goes up from left to right or down from left to right. So for number 1, we're going to start doing the same thing we did before, make a table of values, and we're going to plug in 0 and 1 for x. Now you don't need a calculator for the first one, because when you multiply 0.25 and 0, you end up with e to the 0, which is 1. So 3 times 1 is 3. But for the second one, you do need a calculator to find that other value. So 3e to the 0.25 times 1 is as follows.
Plugging in 1 for x, we're going to type in 3e to the power of 0.25, and 0.25 times 1 is just 0.25, but you can do multiplication in the power, right, and then enter, you should get 3.85.
Alrighty, now that I know that value is 3.85, I'm going to plot those 2 points on my graph, and I know the general shape of the curve. So 0, 3, and 1, 3.85, so close to 4. And we still have this asymptote. So at the x-axis, we have this line that our line cannot touch, but it gets really close to. So I'm going to go ahead and draw that in as well. Now remember, it's always at the x-axis unless we have to shift. Also, we need to state the domain and range. The domain is all real numbers, as per usual, and the range is y is greater than 0, because we did no shifting. Alrighty, on to the next one. Go ahead and make a table, x, y, x is 0 and 1, and we will plug those in to find y. And again, whenever you plug 0 into the exponent, we don't need a calculator to solve that because e to the 0 power is 1. So it's 4 times 1, which is 4. But we do need a calculator for the second.
For number 2, when we're plugging in 1, we are going to have 4 e to the power of 0.5 times 1, which is just 0.5. And we end up with 6.59.
Right, now that we know that y value when x equals 1 is 6.59, we can plot those 2 points, 0, 4, and 1, 6.59. Draw our asymptote, and also draw that curve through the 2 points. The domain, again, is going to be all real numbers because we have x values from negative infinity to positive infinity. And the range, we only have y values from y equals 0 up, or not even equals 0. Sorry, doesn't touch 0, comes really close. So y is greater than 0. All right, number 3 and number 4, we're going to have to do some shifting because we see that x minus 2 and the plus 1 on the outside. So shifting rules do not change. We're going to do the same thing we used to do in lessons 1 and 2. So we are going to figure out what the graph of e to the negative 0.75x is, and then we'll shift it. So plugging in 0 and 1 into that. Right, you'll notice since the r value is negative 0.75, our graph is not going to go up from left to right, it's going to go down. So I have 0, 1, and 1.47. I have my asymptote at the x-axis. And then I'm going to draw a smooth curve through those. So from left to right, this time it is going down. And of course you can shift a graph that's growth or decay. So our normal transformation rules, we are going right 2 and up 1 for both of our points. And then we are also going to move that asymptote up 1 and draw our final line through those points. So our domain is all real numbers. We still have all of our x values. And then our range, we have y values above 1. So it's going to be y is greater than 1. All right, we've got another one to shift. So we're going to start by just figuring out what y equals e to the negative 1.5x looks like by plugging in 0 and 1 into that equation. So we have 0, 1, And then I'm not showing you how to do this on a calculator anymore because I hope you know how to do it, but contact me if you have any questions. So again, since it was a negative number in the exponent, our graph is going down from left to right. So it's an exponential decay. And then it looks like we are going to go left 2 and down 4. So take each of those points, go left 2, down 4, left 2, down 4, move that asymptote down 4, and redraw your curve. Beautiful. All right, this time the domain is all real numbers, shocker. And our range is y is greater than -4. There's a pattern if you haven't figured it out by now. It's that last number. That's our range. All right, we're talking about continuously compounded interest. So we've talked about interest being compounded yearly or monthly or whatever. But if you look at that equation that we've been using, it looks a lot like the equation for e that we talked about in the beginning. So now when it's compounded continuously, or infinity times, we replace that with an e. So our new formula that we're using is a equals p e to the rt. And in math terms, we say PERT. So for this one, the first one, you just deposit $4,000, so that's your principal or your initial amount, and it pays 6% annual interest. Remember to change that to a decimal, so 0.06. And then we want to know the balance after 1 year, so plug in 1 for t. Now I'm going to show you how to do it in a calculator.
So for this one, in your calculator, it should look like 4,000 times e to the power of 0.06, and then it's times 1 because it's just 1 year. You should end up with $4,247.35.
All right, moving on to number 2 in our last problem. You deposit $2,500 into an account that pays 5% annual interest. So $2,500 is your principal, or your initial amount. E to the 0.05 is our rate. And then the first thing just said to write the formula for t years, and then we'll plug in for t in letter B. So for this one, I want to find out how much is in the account after 2 years, 5 years, and 7.5 years.
For 2b, we're plugging in 2,500 times e to the power of 0.05 times 2. So we have to find it after 2 years. Here's a little trick. Since we have to find it after 5 years and 7.5 years, just press second enter. And now I'm gonna scroll back and replace that 2 with a 5. And I'm gonna do that again, second entry, and replace that 5 with a 7.5. That way you don't have to retype in 2,500 times e to the power. Okay, just a little faster way to do it.
All right, hopefully that taught you a quick little trick to figure out these answers quicker. But if you did not get those, here they are again. So each time we're just changing t to the number of years that we want to find out our balance in the account. All right, once you get all this copied down, you are good to go. Hope y'all have a great day. Also, there's a little behind the scenes of how I shot those calculator scenes, so maybe stick around for a few more seconds.
Behind the scenes. Otis. Otis, come here. Come here. See, I had surgery, so I have to wear these combs.